So my name's Aaron Edwards. I'm Field CTO with CloudGenix. Nice to meet all of you. Some of your faces I recognize, other people I've met before, other people are new. It's great to be with you guys. I'm going to talk a little bit at a high level about CloudGenix, the company, and the architecture. So CloudGenix got its genesis back in 2013, trying to build a better remote office network infrastructure. So one of the things we wanted to do is we saw huge problems in networking. The fundamental landscape is shifting, and it did shift, and it caught a lot of the tech companies unaware. If you look 10, 15 years ago when you were building networks, you built networks to data centers. You used private connectivity. You tried to connect back to your resources in your office, in your data center. We saw this titanic shift going when you had products like Office 365 come out, and customers were now saying, you know what, I'm not putting stuff in my data center anymore, I'm putting stuff in the cloud. If you look at how networks are built, they're not built to understand I'm putting stuff in the cloud, they're built to understand I've got an IP address that I want to connect to, and then there's stuff on top of that that has to be layered on. When you're building these networks, we want it to be more intelligent. We want it to understand what's actually going on. Instead of looking at IP addresses and ports and maybe a BGP session if you're lucky, we actually want the network to be intelligent enough to understand what's going on it and how it's actually going. So when I've got users trying to go to Office 365 and use Outlook, are they able to get to Outlook? And did Outlook respond in a timely manner? And use that as the unit of operation for building a network. So if you want to hit next. So the CloudGenix Autonomous WAN is what we designed and built. Basically, at a very low level, what we wanted to do is be able to replace traditional routers, be able to go in and say, these are going to be the devices that bring your network and connect you into the internet and the fabric of the private network and the public network, whatever type of connectivity you have, the LTE network, bring whatever you've got. And what we'll do is we'll make the best, most efficient use of what you have based on what you're trying to put on it. So instead of looking at things as an IP address or a destination, we look at things as applications. Office 365, Facebook, YouTube. All these applications may or may not be business critical depending on what you're doing. And then now that we've identified these applications and we're going to start putting these applications on these networks, now let's take the next step and understand what those applications are and how they're actually working on these different network paths. Once the system can understand how these applications are working, now we can start making better decisions that say, okay, I'm going to send stuff to this application on this network. I'm trying to send stuff to this application on this network and it's not working. We need to correct that real time and send things through a different path that actually works and can fulfill the needs of that application. And then last, but definitely not least, being able to connect to multiple clouds wherever they may be and being able to integrate with third-party companies that are not CloudGenix. So being able to natively integrate with Office, natively integrate with Palo Alto Prisma, which we'll talk a little bit later. So as I was saying, the key of the self-driving network is really to understand a lot of different attributes about the traffic. Is this a? Yep. Oh, sweet. Okay. So if you look at kind of the landscape of SD-WAN, which is what a lot of vendors said we were going to build this product to kind of solve this cloud use case. They take a look at it and they build it based on link attributes. They're really making a better VPN and a better overlay. One of the things about VPN is that you're not always going to have a VPN. You're not always going to have a device on the other side that you can connect to. So when we were building CloudGenix, we said, let's build this network so that it can take any type of connectivity. We don't have to be just tunnels. It can be direct connectivity. But what SD-WAN Gen 1 gives you is kind of this link loss, jitter, and latency at the link level. So at CloudGenix, we wanted to take it to the next step. Bottom one you said? Good. We wanted to take it to the app level. So now we can start fingerprinting the app and identifying the utilization by app. And then get into the whether the app actually works or not. So now that we've identified the app, now we can start seeing success and failures. Did Office 365 Outlook connect? Did my credit card application go through? Did my inventory application be able to place an order? Go ahead, next one. And then if it did go through, how well did it go through? Am I waiting on back-end processes on the server? Is the server waiting to fulfill my request? Or is it a network issue where the network's causing problems and delay? being able to break down where the problems are actually occurring on a per application basis lets us mitigate those problems to the best of our ability, or help administrators know when there's actually a problem that they need to go work with somebody to address. So if there's a server issue, the administrators no longer, people are getting their network administrators with the fingers pointing at them. They can say, look, it's actually a server-side issue. Let's go figure out how to resolve it, versus spending all this time trying to figure out how the network's breaking it when the network is completely not the problem. So this visibility and understanding is key part of building these next generation networks. Go ahead. So then the next step on top of this autonomous networking is, how do we use this to the next level? So how do we take this smart fabric that we're able to build on how applications are actually pathing through the system and create a next generation branch? One of the biggest uses that we see of this is being able to deliver services in a branch in a scalable, elastic cloud manner. So being able to take your WAN from CloudGenix along with security, collaboration, and operations, and say, let's deliver all of these services into the branch without actually needing physical hardware or truck rolls to be able to add and remove services. And so this is what we call CloudBlades. So what CloudBlades let us do is they let us add features and capability to the network without requiring extra hardware or extra systems. So one of the great examples of the CloudBlades services that we have today, we've got a couple different examples that we're working with. Number one, Prisma by Palo Alto. So being able to provide on-demand security at the branch and enhanced features without requiring any hardware. And then Equinix for multi-cloud connectivity using their cloud gateway. Yeah.
Is the CloudBlade, the Blade, just some software that CloudGenix is running, so you're able to run additional services?
That's exactly it. So it's a piece of software that ties a bunch of different things together. So it takes our forwarding plane and intelligently programs our forwarding plane to consume these services at those remote office. So go ahead and go to the next one. So giving a good example here using Prisma. So an onboard security ramp where we're creating tunnels to different Prisma regions based on policy and configuration. Now you can automatically program our forwarding plane to say what traffic needs to go to Prisma. So let's, as a good example, let's say I want to inspect everything, which is the default that you handle with security. You want to make sure everything gets inspected. That's great. Maybe I don't want to inspect everything. Maybe I want to send stuff in a region, site to site directly without going through Prisma. Maybe stuff to my data center I don't want to send through Prisma. Maybe some stuff from my data center needs to get DLP, gets SSL inspected. On a per application basis, you can say, I want to send these apps to Prisma to get inspected that absolutely need inspected. Anything that I know that I don't want to send, you can do that on a per app basis. So again, hooking into our forwarding plane at our very rich, granular per application forwarding, you can now leverage that with these other services to really efficiently deliver this security overlay. So another good example, maybe I have a region in the world that I need extra inspection. Like maybe I'm using the CloudGenix fabric to route between sites, but there's a region that I don't have, and maybe it's a third-party region, maybe I've got additional inspection that's needed because I don't necessarily trust the branches into my network and I want to provide an extra perimeter. That's easy to do. It takes about 2 clicks in the system, and now you can say this domain is segmented off from the rest of my network. And then using another CloudBlade example, again talking about software, is using multi-cloud with Equinix Cloud Exchange. So Equinix is offering a service where they're able to connect all these different clouds and provide fast resources into the different cloud systems. And one of the things that CloudGenix is working on with Equinix is being able to provide virtual resources and spinning up CloudGenix Ion instances automatically in the Cloud Exchange. So now you don't even need to do a physical truck roll and put physical devices in the cloud, automatically spin it up and connect your network into the Equinix Cloud Exchange. And I'm sure these guys will talk more about all of this later on as well. And then talking about Columbia, which of course John just walked out a little bit. Timed that perfect. So go ahead. So that means I can make up stuff.
There you go.
So 10 times better cloud SLA, being able to get applications quicker, better, faster, being able to do integrated cloud security and decouple the policy from the network. And then as John will tell you guys a little later on, there's a huge cost savings that he's seeing in the WAN. I don't want to spoil what he's going to talk about. So